So in question 4, we have a medical researcher who completed a study comparing omega-3 fatty acids supplement to a placebo in the treatment of irritability in patients with a certain medical condition. We have 19 patients who took both of these medicines, and they recorded their data. And we're told that they rated their irritability on a score of 0 to 10. And for each patient, the two irritability scores and the difference in their scores were recorded, and we have this results in the table and the box plots. And we are told that the researcher claims that the omega-3 supplement will decrease the mean irritability scores of all the patients with a medical condition similar to the volunteers who participated in the study. We are asked, is there statistical evidence to support this claim at this significance level? So firstly, we need to decide what variables we will use and what our null and alternative hypotheses are. So we can represent this new variable mu d, the difference in the mean. So d for difference, so difference in mean of a placebo minus omega-3, right? So what we're given over here, the difference of these two. And we need to state our null hypothesis. So our null hypothesis is that the mean is, okay, 0 is that the mean is 0, so there is no difference. And our alternative hypothesis is that there is a difference. So we say that mu d is larger than 0, so the difference is larger than 0, which means that placebo does have a stronger, the omega-3 does have an effect, because they had a lower, right? So 10 means highest level of irritability, so we want the score to be as low as possible, and we need to see whether there's enough statistical evidence to show that omega-3 is indeed helping here, and it's not just random effects. So the way we can do this is by using a matched pair t-test to compare the means. So matched pair t-test. So this is what we will have to use. And what we can say is that the data gathered was random, right? So the 19 patients who were volunteered, and it was a randomized experiment, as we randomized this week stuff, so that works. And we can, well, for usually we would want the sample to be at least 30. Here we only have 19. However, we can see that the box plots are relatively symmetrical, which means that we don't have a skew in either direction, which means that it is safe to assume that we can use these data points for this experiment. So what we need to note some of this down, what I just said. So we can say that the experiment was randomized. So experiment was randomized as it was random in which week they got the treatment. There was no real any logic behind it. And we can also say that the sample size, n equals 19, is smaller than 30. However, we can see that the distributions are symmetric on the box plots. So we can see that on the box plots, we can see that approximately the 50% of the data are equally distributed. The lengths of these segments are approximately constant. So we can calculate the value for the test statistics for the match pair t-test. The formula is going to be x average d minus mu 0 divided by s divided by root n. So let's plug in our values. So the difference is going to be 1.789. Mu 0 here is simply 0. That is our null hypothesis, basically. And we divide this by the standard deviation, which is 2.485, and we divide it by the number of samples, 19. This will give us 0.0028 for the value of the test statistic. What we still need to do is find the critical value for this test, and we have to use 18 degrees of freedom, n minus 1, and we can look in the table that for this, the p-value is going to be 0. So the p-value is going to be 0.028, and the test statistics was 3.138, and the p-values for 18 degrees of freedom here is 0.028. So what we can say is that our p-value is smaller than 0.05, which means that the null hypothesis is rejected. So H0 rejected, which, well, if we reject this, that means that there is a significant difference, which means that the omega-3 fatty acids are helpful in reducing irritability for people with this specific medical condition.